Hello everyone. My name is Professor Urvish Mewada. I am head of the department in the Electrical Engineering Department, Sri Swamner Institute of Technology, Gandhinagar. I am the subject matter of Industrial Instrumentation subject, which is in the 7th semester GTU, and subject code of this subject is 2170913. So this is the second lecture for the chapter number 2, strain gauge. In previous lecture we studied about the introduction of the strain gauge and type of the strain gauges, in which we had gone through the two types, that is unbonded and bonded resistance via strain gauges, and then we derived the equation for the gauge factor, as well as we had gone through the difference between the bonded strain gauge and unbonded strain gauge. Now this is the topic number 2, and this is the subtopic from the types of the strain gauge, and this is the second type. It is the wire strain gauge. Now the types of electrical strain gauges, in this is the second type, that is wired strain gauge. So from this diagram you can see that this is the means substrate on which a wire is wired, or we can say a shape. You can see over here a wire which is engraved, or placed like this. So this is the direction of the strain we can measure with the help of this grid type strain gauge. So basically this grid type strain gauge measuring the longitudinal axis which is parallel to the wire element, means in this direction it can measure the stress and the strain. Now when any object is located along the transverse axis, means it is perpendicular to the direction of the strain, then it can be it is being measured along the longitudinal axis, so affected, and this will produce an error. Means uh, if you place your object in the perpendicular direction to this wire, so due to this the longitudinal axis will also affected, and we cannot properly measure the strain gauge strain with the help of stress and strain with the help of this grid type strain gauge. So this might will get produce an error in the response of the gauge. So a certain amount of strain is present along the transverse sensitivity has to be considered while measuring the output of the final stage. No, now uh, due to this limitation of this grid type strain gauge, in order to obtain the accurate result we must compensate the gauge error. Now how can we compensate the gauge error? We can place number of wires on the surface, or we can say gauge, so we can measure longitudinal as well as the transverse directional stress and strain with the help of this strain gauge. So why this is called the grid type? Because you can see the shape of this wire which is placed on the surface is like a grid, or like a shape of grill. So this with the help of this type of grid type strain gauge we have a limitation, because it measures the stress in the longitudinal directional, and in the if we place our object in transverse direction it may produce the error. So to minimize this error we have the second strain gauge, that is ROSETTE type, or we can say reset type strain gauge. Now this is the diagram of reset type strain gauge. Over here you can see that number of wires which are placed on the base, or the surface. So again over here you can see that this is the first shape, and means this is, suppose we consider this direction, so in this longitude directional we have this wire, transverse direction we have this wire, and in cross means uh, perpendicular to both, means here in one bracket this wire is creating a 45-degree angle. So the placement of the wire is like this in the rosette type strain gauge, or we can say reset type strain gauge. So basically it has three elements, or we can say it has three elements strain gauge, and the angle between two longitudinal, means suppose we consider this direction, this is the longitudinal directional, and this, suppose we consider this direction, then this is again a longitudinal directional for this. So two longitudinal gauges, axis is 45 as I explained, means this is the placement of the wire, and it produces 45-degree angle between each two elements which are placed axially. Now for a component, if the axis strain is unknown, the strain gauge transducer can be used to determine the exact direction. So because of the placement of wire, means because of the placement of the wire, we can determine the direction of the stress applied, because in the previous diagram we have only one element wire, and due to that we can measure the applied stress in the direction of the placement of the wire. But over here you can see that we used three elements, and because of this three elements we will have an advantage that we can measure um, uh, exact direction of the stress applied. So this method requires several strain gauges. So these are the terminal through which we can connect this gauge into the balance bridge circuit, and this wire is nothing but the strain gauge. And if we applied a force on this wires, the expand because of the expansion of this wire, or we can say due to the tension, due to the stretching of this wire, the resistance of this wire will change, so as the voltage passing through this wire will change, and we can measure that stress applied in terms of electrical signal. Now the in this method it requires the several strain gauge, because the strain gauges are placed a point on a member surface, means this is the base on which we place this wire, and the angle between the gauges are known, means we know it is a predefined angle between each point of cross section, and we know the angle between each element. So it is the predefined, or we can say mm, pre-decided angle between gauges, and magnitude of the strain is measured is to used in geometrical determination of the strain in the member, means a strain or stress we applied on this surface. By applying this stress and strain, we can determine the geometrical direction, or we can say direction of the stress applied with the help of this rosette type strain gauge. And this type of strain gauge most commonly used strain gauge for the transducer or for the industrial instrumentation purpose. So this is the second type of wire strain gauge. Now we move towards the third type, and that is torque type strain gauge. So the shape of the wire, placement of the wire, you can see over here, it is like a shape on the tire surface. Due to such shape, we can measure a stress applied on this strain gauge in both the direction. So due to this, it will cover a whole surface of means strain gauge, and whenever we apply stress on this, so it can measure a stress applied in longitudinal directional. So this is torque type strain gauge, and this is again a second shape. We can place a conductor like this also, so we can cover more surface of the strain gauge, and we can measure the stress applied on the wire. Now the fourth type is helical type strain gauge. So for helical type strain gauge, over here you can see the diagram. It is uh, means cross point of X shaped frame. Means from this you can see that it is in both the direction, and this is volute type shape of the wire which is placed on the base. So it is also called the each to foil strain gauge, because due to with the help of foil, we uh, we uh, uh, we do the engraving of the wire, and that is why it is called each to foil. And the strain gauge is generally latest developed in the strain gauge, and such kind of strain gauge employs in the PCB design technique also. And the electrical as well as the physical characteristic of etched foil strain gauge, uh, basically it is very superior in comparison to bonded wire strain gauge. So this type of strain gauge means we can use for industrial purpose to measure the strain and stress applied. Now basically the six of the strain gauge is dependent on the type of application, and the strain gauge can be as small as 3 square mm. It is the gauge of the wire, and generally they are larger but not more than 2.5 mm long. And as we know that as the gauge size is small, it can be used widely for the stress and strain measurement for the industrial purpose. And means they are larger but not more than 2.5 mm long and 12.5 mm wide. So this is the criteria for the criteria, or we can say dimension, for the strain gauge which we can use for the stress and strain measurement for the industrial purpose. Now uh, this is the summary of wire type strain gauge. Basically it is available, means resistance of the strain gauge, means the wire which we use, the resistance of that strain gauge is from starting from 120 ohm to around 1000 ohm, means 120 ohm, 350 ohm and 1000 ohm. In different variants it is available, and we can select the strain gauge according to the purpose of the measurement. And means due to this it results in a lower sensitivity, means sensitivity of this gauge is small, or we can say low, compared to the bonded and unbonded strain gauge. And uh, if we want to use this strain gauges for higher sensitivity, uh, we have to be used to achieve more sensitivity. We need to apply more voltage. And in the bridge circuit, voltage is limited by the maximum current carrying capacity of the wire. So each wire have its own current carrying capacity because of its gauge. Means as we know that R is equal to rho L by A, and cross section area defines the resistance of the particular wire gauge. And if we use such kind of strain gauges to measure the strain, then we need to use it for a particular range, say 120 ohm, 350 ohm and 100 ohm. So therefore for the higher bridge voltage have to be used to achieve the more sensitivity. If we want to use this strain gauges for higher sensitivity, we need to apply the higher voltage. And this can be controlled or limited by the maximum current capacity of the wire, and it is typically 30 milliampere. Generally it is available for such kind of wire strain gauges. So this is the wire strain gauge. Now uh, this strain gauges have certain means uh, characteristics for reproducible and excellent result. Generally it is desired that the resistance wire strain gauge should have this characteristic. So if this characteristics satisfied, then we can use that gauge for the industrial purpose with minimum error and with good sensitivity. So higher value of gauge factor results the higher sensitivity that we already studied in the previous slides. Now means if we take a strain gauge having the having good gauge factor, or strain gauge material having good gauge factor, then that strain gauge should have a higher sensitivity. Now it should have the low resistance coefficient, because it affects the accuracy of the measurement. If the resistance coefficient is higher, then the accuracy is lower. So this is the second point, second characteristic that must be satisfied. Now the third characteristic is it should not have the hysteresis effect in its response. If hysteresis effect is present in the strain gauge, then it can generate the error. So we need to minimize the hysteresis effect while we measure stress or strain with the help of strain gauge. And the strain gauge should have the high resistance as possible, because if higher resistance if we take higher resistance material, then we can use it for the large range. Now such type of strain gauge should have the gauge should have linear characteristic over the entire range. Means as we give the input, according to the input it should give the output, and it should perform. So therefore this type of strain gauge should have the linear characteristic. Now again it should have the good frequency response. If frequency response is good, then we can use it for the dynamic measurement. Means an industry where required continuous fluctuation in the input quantity is to be measured. So whenever input is continuously changing, at that time our transducer should respond properly. So that's why to need to improve the dynamic measurement ability or characteristic, we need to keep good frequency response for the we need to select the good frequency response transducer or strain gauge for the measurement purpose, or strain gauge wire strain gauge. And the adhesive material should be of quick drying type, and it should have the characteristic. Means it should be the insensitive to the moisture. Means if moisture contents are present in the industry, so this the adhesive material could be weak, and the strain gauge will not stick properly on the surface. So the adhesive material generally we use, that is ethyl cellulose cement and nitrocellulose cement and bakelite cement. Also we can use the epoxy cement. So such kind of adhesives we can use for the industrial purpose, for means for the better performance of the wire strain gauge. Now the connecting lead materials generally we use that have low stable resistivity, because if the resistivity of that material that leads is high, then we cannot use that gauge for the higher range. And as well as low resistance temperature coefficient. Means we need to select the strain gauge should have the low resistance temperature coefficient and low stable resistivity. So when such characteristic and such conditions are satisfied, about the strain gauge, we can say we can use that wire strain gauge for measurement purpose. Now the next is bonded metal foil strain gauge. So this is the shape and this is the diagram of foil type strain gauge. So for this generally we use rolling out a thin foil resistive material. Then that rolled material then cut away in the parts of the foil by a photo etching process. And it is nothing but the engraving. And to create this required pattern, grid pattern, we use the photo etching process, and such strain gauges are called the bonded metal foil strain gauge. uh, and they are the extension of the bonded metal wire strain gauge. Basically, the bonded metal foil strain gauges are similar material to wire strain gauges, so they are used for the stress analysis application and for many transducers. So this is the criteria, this is the characteristic of this kind of foil type strain gauge. And the metals and alloys used for the foil and wire are generally, we use the nichrome constantan and iso elastic and nickel and platinum. So if we use such materials, then uh, we will have the good means sensitivity of this strain gauge, and we can have the good stress and strain measurement range also. Now uh, this gauge have the greater heat dissipation capacity. So this is the plus point of bonded metal strain gauge, because if it should have the great heat dissipation capacity, so it comparison to the wire wound gauges. So if the large it has the large surface area for the same volume, so because of this it should have the good heat dissipation capacity. Now again, this gauge can be fabricated on the large scale, and it can acquire any shape, because a thin foil, or we can say the thin films of the foil are used for such materials. As we explained, that these are the material, and due to this we can give any shape to the foil type strain gauge. And in case of etched foil gauges, a layer of bonding of a strain sensitive material is applied to a thin sheet of the paper to the bakelite. So this is the foil which is mounted on the base, and base may be made up of a bakelite material. Again, it is a longitudinal, it has it should have the means it can measure the longitudinal sensitivity of the foil gauge is 5% more than the resistive wire strain gauge. So this kind of strain gauge is superior than the resistive wire strain gauge. And this foil the hysteresis of this foil gauge is say one third to the one half of the resistance via strain gauge. So minimum hysteresis will produce minimum error, and such kind of gauges can be widely used for the industrial measurement purpose. So again, the part of metal that is to be used as wire element, it is covered with an appropriate masking material, and this masking material provides generally the mechanical protection, as well as it protects the wire from the atmospheric changes. And the etching solution is then applied to the unit, and due to this it removes the unmasked part of the metal, and this will keep the grid structure intact. Means generally it provides the whole grid structure into the base. And a smallest gauge size about 0.3 0.8 mm long. So from this you can imagine the size of the gauge. It is in 0.38 mm long, uh, and it is very sensitive and it is very accurate compared to the bonded wire strain gauge. Now it can be applied to curved surface because we use thin films of the foil, so we can give any shape to that foils, and minimum safe band radius can be as small as 1.5 mm. So from this you can imagine that you can give your desired shape to the strain gauge because we use thin film of the strain gauge wire material, strain gauge material. Now the gauge resistance of this foil type gauges are basically 120 ohm, 350 ohm, 1000 ohm, and gauge current is 5 to 40 milliampere, and the gauge factor varies from 2 to 4. So this is the means availability of the such kind of strain gauge in the market. Now resistance films are generally vacuum coated with ceramic film, and it is deposited on the plastic backing for the better insulation. So again, that plastic backing provides low thermal conductivity, and due to that the person who is near to that gauge will not get harm from the heat generated due to the measurement. Now the advantages of the foil gauge, basically the advantages of this foil gauges are, first is foil is more thin, as we already gone through this, than the wire, so it moves, it is more flexible, so we can give any shape to this foil type strain gauge for our measurement purpose. And it gives it gives a longer area for the dissipation at heat generated by the current flowing in the gauge. And the third advantage is, due to the photo etching technique it is used over here, so it is possible to produce the foil gauges of same characteristics whenever we require. Now the fourth advantage of this foil gauge is, the foil gauge has much smaller dimension as compared to the other types, so we can use it very widely for the industrial purpose, and as per our requirement, where the means the it when the space is very small or very less, at that place we can use such kind of strain gauge. So this was the foil gauge strain gauge. Now this is the most important theory and most important strain gauge of the chapter, that is semiconductor strain gauge. So we'll start with the semiconductor strain gauge diagram over here. So this rectangular portion means the horizontal lines are lines indicates this is the wafer of the semiconducting material. So this is the semiconducting material through which a wire take out, and on which we can connect, with the help of this wires we can connect this gauge in the bridge circuit. Now this wire is made up of gold, and these are the terminals through which we can connect this gauge in the bridge circuit. This is the base on which the semiconducting material and the wire both are placed. And for this kind of semiconductor strain gauge, generally it is used where the high gauge factor is desired, and therefore higher change in the resistance can be measured with the good accuracy. Means wherever the gauge factor is higher, so we can measure higher resistance, change in the higher resistance, and it can be measured with the good accuracy. So Uh, the second property of such semiconducting strain gauge is the resistance change as strain applied. So it is nothing but the piezoresistive effect, means the resistance of the resistance of the semiconductor gauge changes as strain is applied to it. The semiconductor gauges depend for their action upon the piezoresistive effect. So change in value of resistance due to the change in resistivity, so that is the piezoresistive effect principle. And change in the value of the resistance due to the change in the resistivity. Similarly, we use silicon and germanium wafers, means material for the semiconducting strain gauge. And wafers means we use thin foils and thin plates of the silicon and germanium material. Both are the semiconducting material, and the thickness of this wafer is 0.05 mm. And from this dimension you can imagine that it is very 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 thin. And bonding them on the desired insulating substrate like Teflon. Generally we use Teflon material for the substrate on which we mount this silicon and germanium wafers. And the leads which we taken out from the semiconducting strain gauge, it is gold leads, are used to making contacts. And it has certain advantages, so we'll see the one by one. First advantage of this semiconducting type strain gauge is it has a very small size, so it can be used where the place is space is a problem, or we can say less space in the industry at which we can use this. And it has high gauge factor, as you already gone through this word, high gauge factor. And so therefore the sensitivity and accuracy is good. It provides high accuracy because it has higher gauge factor and higher strain resistivity. So it can measure large strain with the help of we can measure large strain with the help of semiconducting strain gauge material and strain gauges. Again, these gauges are very means it is the disadvantage of the gauges. The gauge is these gauges are very sensitive to change in the temperature, because as we know that silicon and germanium both are the semiconducting material, and semiconductors generally operates on the room temperature. So whenever the temperature fluctuation is occur, at that time due to it is due to it is sensitive to the change in temperature. So means it can generate the error where the continuously temperature changes. Now linearity of this gauge is poor, because of the as the current pass through this material, it will get heated up, and due to the heating means it loses its linearity during the measurement. Now as we gone through the foil type and semiconductor strain gauge, so this is the difference between these two according to its characteristic. So first characteristic have is gauge factor. So for foil type, gauge factor is small. For semiconductor type, it is very high. So it shows the sensitivity, means for small for foil type strain gauge, the gauge factor is small, so it has small sensitivity compared to the compared to the semiconducting type. Cost is foil type is low, and semiconductor type is high. And then temperature stability, it is we can say very good for the foil type, and for semiconductor type it is very poor. Linearity is good for the foil type, and for the semiconductor type it is poor. Sorry. And fatigue life, generally it is low for the foil type, and semiconducting type it is high. This is the size it is a printing mistake over here. It is size, and size of the foil type is large, and semiconducting type strain gauge is small. So such kind of difference can be asked in your GTU exam. So this is nothing but the summary of both the strain gauges, foil type as well as the semiconducting type. Now, generally strain gauge material has means it should have good characteristic, means the material is to be used for strain gauges is selected from the following consideration, means it must be satisfied this consideration, then and then we can use the strain gauge material for the strain measurement. So the first strain gauge material consideration is high gauge factor, that we already know, and it should remain constant over a wide strain in the temperature range, and uh, the it should have the low temperature sensitivity, and because if low temperature sensitivity is there, then the output response is linear. And the third is minimum thermoelectric tendency or connection, and the fourth is high yield point and endurance limit. Yield point means a point at which a material loses its property. So it has high yield point and endurance limit, because we are measuring stress with the help of this gauge material. It should have good workability, and means it should have a negligible hysteresis. If hysteresis is more, then it affects the linearity of the property, means property of that material, and the properties, the characteristic is linearity, it affects the linearity of this gauge material, the gauge, sorry. And it should have the low cost, so we can use it for our application, different application. And some commonly used material for the strain gauges are shown in this table. So this table shows generally we use the iridium, platinum, isoelastic, nickel, silicon, semiconductor. So the interesting thing about this materials are the gauge factor. So from this you can see that the advanced material generally we use having the gauge factor is 20, and the isoelastic having the highest gauge factor, so its sensitivity is high. So that's why it is suitable for the dynamic strain increments. And we are starting from the first, the advanced material generally we use copper and nichrome. So 57% copper and 47% nichrome, so gauge factor is 2.0. And if the gauge factor constant over a wide range easily workable, then commonly used for the measuring static strain. So such kind of materials can be used for the static strain. The second material is iridium, platinum. This is the composition. You can remember this composition. Such kind of the materials which use for the strain gauge can be asked in your GTU exam. So just remember this composition. And the gauge factor of this iridium, platinum is 3.1, so it is suitable for the higher temperature above 1000 degrees centigrade. Then isoelastic, this is the composition of the isoelastic, and the gauge factor is 3.5, so it is suitable for the dynamic strain increments. Then nickel, it is having gauge factor 2.5, so it is suitable for the dynamic temperature work up to 1200 degrees centigrade. And the silicon and semiconducting material, means generally we use, it has the gauge factor -100 to 150. So it is means brittle and not suitable for the large strain measurement. So these are the materials generally we use for the strain gauge. So each material has a different property, and according our measurement requirement, we can use a strain gauge having means having a composition of material, means different composition of material as per our requirement. Now, after this topic, the assignment questions means the worksheet question and the assignment questions both are mentioned in this slide. The bolded question is your assignment question, and this question number 1 and 2 are your worksheet question. So the questions are: what is the relation between gauge factor and the sensitivity of the strain gauge? The second question is: which are the adhesive materials generally we use for the wire strain gauges? And the third question, which is for the assignment: what is wire strain gauge, and list the characteristics required for the good wire strain gauge. The fourth question is: explain semiconductor strain gauge with necessary diagram. Also enlist the advantages and disadvantages of the semiconducting strain gauge material. Uh, then enlist the characteristic of the material used for the strain gauge. Also name the materials with its gauge factor and composition. So for this questions, the related instructions are written below the assignment questions. You can take the snap of this and you can note it down. All the instructions which are related to assignment and worksheets both are written in this instruction table list. And if you have any doubt and any query related to this topic, feel free to call me, and you can message me and you can call me anytime. With this, I'm done with this presentation, with this lecture. Thank you very much, student. Jai Swami Narayan.